Let's take a look at the questions on homework number 27. First, we'll start with elimination method, that is solving a system of equations or a two-variable sentence, finding both the x and y values. There are two ways to solve a system. One is algebraically, and the other is graphically, using your graphing calculator or actually drawing them. My suggestion for this practice is to solve it algebraically and then check your answer using the calculator so that you get practice with both methods. Alright, let's take a look at this first question here. 5x plus 8y equals negative 88, and x minus y equals negative 2. Let's take a quick screenshot of these equations, and we'll get started here. So this sentence here is written in standard form. The second sentence is also written in standard form. And to use elimination means that you will multiply one or both sentences to eliminate one variable so that you can combine the sentences together. So I'm going to choose to multiply everybody in this sentence by negative 5, giving me negative 5x plus 5y equals positive 10. My original top sentence will remain the same. 5x plus 8y equals negative 88. There's my elimination. I get 13y equals negative 78. Divide both sides by 13. And I get y is equal to negative 6. Since y is equal to negative 6, now I simply substitute this value in negative 6 into either one of these sentences. This one, that one, or even my modified sentence. I'm going to erase and replace the letter y, and its substitute is a negative 6. Don't forget that negative sign. So x minus minus 6 is x plus 6. So x is equal to negative 8. So my two solutions are negative 8 first, because that's x, and negative 6 second. Negative 8, negative 6. Now before I check this answer, I could also use my graphing calculator, but in order to do that, both of my sentences would need to be in y equals form. So my y would need to be by itself. So here's my second sentence. If I isolate y, I'm going to subtract x, and then I'm going to divide by negative 1, giving me x plus 2. That's one sentence. My other sentence here, 8y equals negative 5x minus 88. Divide everybody by 8, and it's okay to get a fraction because you're not going to do math with it. You're simply going to type it in the graphing calculator. So this is how you use your graphing calculator. There's a lot of buttons to press, so pay attention. Number 1, put in both sentences here, y equals x plus 2. The second one is fraction, negative 5/8 with an x on the side, minus 11. Now I could certainly look at the graph by pressing graph, and I can see my two linear functions being drawn, and they will show me the point of intersection. But to actually calculate these numbers, I should press second, trace. That's what gets me to the calc menu. I want to calculate the intersection, number 5, and it's going to ask me several questions. Look for this blinking X cursor. It's asking you, am I on the first curve or line? Press enter. Now it's going to ask you if it's on the second curve or line. If you can't see it, you can press this left and right arrow to move that cursor. There it is. Press enter. Now it's asking if I want to make a guess. Press enter, and there it is. Confirms for us that we are correct. X is negative 8 and y is negative 6. Let's go back to the second topic, which is substitution. To solve by substitution, means that your questions are not both in standard form, like this one here, and you're going to use this isolated variable as a substitute. So I'm going to erase the letter y and replace it with the substitute. So this whole expression is going to go into that position. It's combining the two sentences together so that you only have one sentence with one type of letter. This remains, the y is erased and replaced with the substitute expression. Now I'm going to distribute and combine. Oops, I was a little too early. I'm going to subtract 9 from both sides, divide both sides by -10, and I get my answer, -2. Right? X is -2. Now I'm going to take this value and I'm going to substitute it in for this letter. Right? So -3, erase and replace. The substitute this time is -2. So we have 6 plus 3 equals y, or y is equal to 9. Again, you can rearrange this second sentence to be in slope-intercept form, where y is by itself, and you could type it here into your y equals button to check your math. So -2 and 9 is our solution. -2 is x, put it in the right place, and y is 9. That's how you compute the substitution method. Now let's go on to some vocabulary questions here. So they're asking you if these mappings are functions. So each value of the domain can only have one arrow coming off of it. So this is not a function, since there is one number in set A, the input, set A is the input, where there is multiple mappings, right? Number 0 has multiple mappings to the output. So I'm looking for things that say output and also set B. Let's try one more. There are 2 mappings coming off of the input, so this is not a function because there is one number in the set A input where there are multiple mappings to set B the output. Next one, set A, single arrow, single arrow, single arrow, single arrow. This represents a function, since for each number in set A, the input, there is only one mapping to set B the output. All right, let's go back and take a look at whether a set of points is a function. So again, your input can only go with one output. So you're looking for repeating values here. So you see here, this has a 9 and a 9. That's not a function. This has an 8 and an 8. That's a repeat, not a function. This has a 0 and a 0. That's a repeat. That's not a function. So the first one has no repeating x values with different y values. Determine if a graph is a function. To determine if a graph is a function, what you do is you take your vertical line test, right? You draw an imaginary line. You draw an imaginary line and you scan down your graph, right? You're moving this imaginary line down your graph. And if you touch the function in more than one location at the same time, you are not a function. You fail the vertical line test. This is not a function. It fails the vertical line test. Again, vertical line test, scanning, scanning, scanning. I never touch it in more than one place. That is a function. Scanning, scanning, scanning. I never touch it in more than one place. That is a function. All right, let's take a look at the next task. Visual domain and range. So be careful that you're reading the vocabulary correctly here. To determine the domain means to look at the spread of the x number line, to look to see how far to the left and right on the x number line, how far to the left and how far to the right, how far to the left and how far to the right does the graph scan. The next thing that you need to know is that you can use inequality notation or you can use interval notation. With interval notation, you have to know the leftmost value comes first, the rightmost value comes second, and then you choose the boundary by whether the circles are open or closed. So interval notation here would have closed and closed. That's 2 brackets like this. The farthest left it goes is -2. The farthest right it goes is +10. That would be correct interval notation. If you're using inequality notation, because it says domain, you have to have an x in the middle of either 2 less than signs, 2 less than signs like this, or 2 less than or equal to signs like this. But it's always going to be less thans. Because these are solid circles, we're going to need 2 less than or equal to's, and we need an x in the middle, not a y. The y in the middle is for a range, not a domain. So -2 is the least, +10 is the greatest, and we could submit it using either method. Right, so they'll show you here the 2 possible answers. Right, they'll show you here in the explanation. Again, this one is a domain. How far to the left, how far to the right. These are both closed, so I'm going to use 2 brackets. -7 is the least. +5 is the greatest. So I'll submit using interval notation this time. My next question is determine the range. The range is how high up and how far down your graph goes. This is the highest up it goes. This is the lowest down it goes. You'll notice they both have closed circles. So that would require either 2 brackets or 2 less than or equal to signs. If you're choosing the inequality method, a y goes in the middle this time. Now be careful, you're scanning the y-axis. So the highest is, the lowest is -7. Right here, -7. And the highest is -2. Let's look at greatest common factor that we learned this week. So I'm looking to divide each of these values here. To factor an expression completely, you're going to look first for a GCF, a greatest common factor for either the numbers, the variables, or both. So I'm looking here at 72 and 40. 40 is the lowest number, so I'm going to focus on the factors of 40 that I know. 4 and 10, 5 and 8, things like that, 2 and 20. So I'm looking for the greatest number that I think can also evenly divide into 72. So I already know that 72 can't be evenly divided by 10 or 20, so I'm going to start going down like, 72 divided by 4 would work, but so does 72 divided by 8. Right, so when I think about the factors of 40, I know that 8 is larger factor. I know that 40 also has factors of, 2 and 20, right? But 72 divided by 20 is not evenly divisible, so that's not the factor. So I'm going to go with dividing by 8. So technically, I'm thinking about writing this as everything being divided by 8. And so to undo that, I'm going to times everything by 8 that remains. So 72 divided by 8 is 9. The x to the third remains the same. 40 divided by 8 is 5. So that's our final answer. 8 times the quantity, 9x cubed plus 5. Sometimes you can factor out more than just a number, like this one here. 40 and 16. I know that 16 has factors of 16 and 1, 4 and 4, 8 and 2. So I don't think 40 is divisible by 16, but you can always try. So then I go to the next factor, which is 2 and 8. So 40 divided by 8. I already know the answer, but this is how you would guess and check. 40 divided by 8. So you know that, okay, if I divide by 8, I remain with a 5. So let's see here. If I'm dividing everything by 8, and then I look at my variables. I have 4 x's here, but only 2 x's there. So the most the second term can give away is 2 x's. So 8x squared is my GCF. What remains after I divide here is negative 5x squared minus 2, and there are no x's left. 8x squared minus 5x squared minus 2. All right, next topic is dots, or difference of two perfect squares. The reason you get a difference of two perfect squares is because that middle term disappeared because you had inverses to begin with, right? You had a plus or minus combination. So what we're going to do is we're going to set up our plus and minus, or sum and difference combination. We're going to square root the first item, right? This is what we're doing in our brain. And then we're going to square root the second item. So we square root numbers, but we don't square root exponents. Exponents are cut in half. So 1 plus 11x, 1 minus 11x. And don't commute these terms, because their order is important. Let's try another one. Again, it's a difference of two squares, so I know that I'm going to end up with a sum and difference. Square root the first, so 2 and 2, and square root the last, 5x and 5x. One more time, you need a sum and a difference, right? So we always start like this. And then we square root the first, 10 and 10. And we square root the last, x and x. All right, next topic. Identify the function type. We've been doing this since September, so hopefully you feel confident with this. This is a curve upwards, so it is exponential. This one is a curly cubic, right? A cubic, but since it is sideways, it's a cube root. Cubics are the curlies that go up and down. This is a sharp V shape. That's an absolute value. All right, last topic. Select the equation from a graph. So we know that we have some exponential function here. And what you can do is you can take each of these. If you're unsure, you could take each of these and you can type them into your graphing calculator, into the y equals button. Anything that's there you should clear out. You press your y equals button, clear out anything that's old, and you can start typing some things in here. Now typically our exponential functions move in this manner. The fact that this one is below the x-axis or reflected over means that it is going to have this negative sign in the front because it is reflected over the x-axis there. So I know that I can eliminate these two, but even if you didn't know that, you could type them all in here. You'll also notice that my graph is shifted away from the origin, down 1, shifted down 1. So you can see that here as well, this shift down 1. So I'm going to start with that, take a look at it. I'm going to type negative, parentheses, 1/4, raised up to the negative x power, and then I'm going to put this -1 over here on the side. Let's take a look at our graph. Here we see the asymptote and then the dip. So I was able to use some thinking of my knowledge of these graphs, but you can certainly just type in every single one of these choices. Okay, so we'll notice that this one is also below the x-axis. It's been reflected down. Okay, and we can kind of look at this growth or decay. I have a 1, then I'm over here at 2, 4, then, I'm going down over here, past the 3. So I can see that this is definitely decay. It's going to have a minus sign in the front. So I know that since it's decay, These are going to be wrong. So let's take a look here. I see that it hasn't shifted from the origin, so I'm going to try this one here. Let's take a look. Whoops. I'm going to put a parentheses here. On my negative x. I'm going to put my plus 1 on the top. And then, whoops. Let's delete this and this. Oh, the parentheses disappeared. Alright, am I happy with how it looks now? Yes, let's take a look. Oh, it keeps taking them away. I guess it doesn't matter. Let's take a look at the graph. Asymptote along the axis, a dip down, and that looks perfect. Alright, that concludes our homework 27.